Okay, all right. So, sorry for delay. Very good evening to all. Are you able to see the screen?
Yeah, good evening, sir. Yeah, I can.
Okay, thank you. So, I welcome you all in this today's session, that is session number 7. And in this today's session, we are going to see the load flow analysis for power distribution system for the radial distribution networks. So, this is the module number 4. So, beginning with this load flow analysis, or that we also call as power flow analysis. What are the purpose of load flow studies? Load flow analysis or studies are performed to know the steady state operating condition of a power system. And in power system, powers are known quantities rather than currents. And therefore, these equations used in load flow studies are in terms of power, not in the terms of currents. And these power flow equations are nonlinear in nature, and we solve these equations using the iterative techniques. In the undergrad course, we have seen load flow analysis using this Newton-Raphson method, Gauss-Seidel method. But here for this distribution networks, we will see how uh, we generally use this backward-forward load shift method. So these load flow studies are used to perform this planning, operation, economic scheduling, and exchange of power between utilities. And these transient, contingency, and stability studies are the required load flow analysis. So these are the general things about the load flow analysis. What is the load flow analysis or power flow analysis? And let us come in the terms of power distribution networks. So we know that this power distribution networks are of radial in nature. And for this radial distribution networks, we perform backward forward shift load flow algorithm. That is that we are going to see, and all the problems in this current assignment are based on this algorithm only. And what are the things that this algorithm is required? We cannot perform Newton-Raphson method or other transmission network algorithms like Gauss-Seidel method and fast decoupled algorithms. There are many algorithms that we approach in transmitter networks, but we cannot apply in this distribution networks. And due to some special characteristics of distributed networks, that's why these algorithms failed in the distribution networks. And we know that the characteristics of distribution networks due to which these algorithms failed, that are radial in nature of these distributed networks, or you can say weakly meshed networks, and this high RYX ratio. And due to distributed generation, we could not apply this Newton-Raphson method or Gauss-Seidel method that we apply in transmitter network algorithms. So come to this how we perform this radial distribution networks, that what are the steps that we need to follow before we apply this radial distribution, before we apply load flow analysis for radial distribution networks, that is backward forward load shift method. First thing what we need to do is we need to draw the single line diagram for a typical distribution network. And we know that the single line diagram is drawn for this balance system. So if this system is balanced, we first draw the single line diagram for a typical distribution network and then prepare a data file, node data, line data. So there in your system there may be different number of nodes. So there are in that node we have to select one select node or substation node. The substation node we refer to it as uh, select node or substation node. And we know that the select node having this voltage and phase angle is considered as 1 and 0 angle respectively. And for load nodes, we considered uh, we categorized it as type 0, while this select node we categorized it as 1. So with this voltage magnitude and delta for load nodes, we need to find out with respect to this reference node, that is slack node or substation node. And for load nodes, what are things given? The things given for load nodes are active and reactive power. So if we have to prepare data file based on the node data and line data. So the top one is the node data and this below one is the line data. So for line data, what are things required? We need to know this its impedance, that line resistance and line reactance. So after making this node data, we will make this line data. And for line data, these things are generally given in the problem, this line resistance and line reactance. Now now the next step is we have to convert all the quantities to per unit quantities on appropriate base quantities. So we have to specify the base quantities, what is the MVA base and what is the kV base. So we need to specify base quantities, and all the quantities given in this node data and line data we need to convert in per unit values. And after making this data file, we can start our load power flow algorithm. So first thing is that we have to make the data file, and after making data file, we convert all the quantities in per unit quantities. So the actual values first we put in this data file, and then uh, with the with help of base quantities, we will convert the data file into per unit quantity. Now, after preparing the data file, we have to apply the forward and backward sweep load flow algorithm. For that, what we do is that first we will calculate the current of each load. So at the load node, we note the active and reactive powers flow. So we can easily find the load current at that respective bus. So for the load nodes, we can find the load current at bus I. So this we represent at I represents the bus I, Vi minus jqi upon Vi conjugate. So this is very simple. This we got from the conventional equation, that is S equal to apparent power equal to Vi conjugate, that we write it as P plus jq. And if you take conjugate both side, S conjugate equal to V conjugate into I, then it becomes P minus jq, and therefore we can write the current value at P minus jq upon V conjugate. So here we have printed the load current at bus by IL. So IL equal to Pi minus jqi upon Vi conjugate. After finding the load current at different load nodes, we will find the line current starting from the end of the feeder. So you note the load current at different load nodes, and then we will find the line current from the end of feeder. So sir has already solved one example, has taken one example in lecture number 19. You can refer to that lecture, and you can understand more how we apply this, how we will find this line current with the help of that is we call it backward sweep. So it is very simple. If you have we will solve problem also today. So after finding the load currents, we will find the line current that starts from the end of feeder, that we call it backward sweep. And after finding the line current, then we apply the voltage at each bus starting from the first bus. Why we are applying the calculation of voltage from the first bus? Because the voltage at substation node or select node or reference node is known. We have taken it as reference one angle at the zero. So we will find the voltage at at the bus that is just beside of the substation node, and we just follow the next node. So that's why this algorithm is called as backward suit and forward suit. Why it is called backward suit? Because we first find the line current from the end of feeder, and then we will find the voltage at each bus from the first bus, because the voltage at first bus is known. So in the second, we are applying in backward sweep, we are applying KCL, while in the forward sweep, we are applying KVL. And what are things we have assumed in this load flow algorithm? We have assumed that unidirectional flow of power. And with the help of this load flow algorithm, we can determine both voltage profile and power loss of network. And this, the general statement you can remember is that about forward and backward sweep is that we will first find the line current or branch currents that are updated through backward sweep, and then node voltage are updated from the forward sweep. So these are some of some general points about backward sweep and forward sweep. So with the help of backward sweep, we determine the branch or line current, and for this for applying the backward sweep, we apply the KCL, Kirchhoff's current law. And for this backward sweep, why it is called as backward sweep? Because this computation starts from the in nodes or terminal nodes, and this backward sweep require more computation, needs more computation, while the forward sweep just opposite of backward sweep. Here apply KVL, Kirchhoff's voltage law, and in this forward sweep we determine the final output of load flow algorithm, that is the bus voltage. So in forward sweep we determine the bus voltage, and here the computation starts from the slack node or reference node or substation node. So if you apply this backward forward load sweep algorithm, then what are the, since this is iterative approach, so what are the termination criteria that algorithm should know that when it has to terminate, when it has to stop? Real algorithm should stop and it should give the final output or final result. If you don't apply this termination criteria, it keeps on running. So it has to follow either one of them. Either it you set this maximum number of iteration, that you should go till this number of iteration, or you provide some tolerance or accuracy. And what is this tolerance or accuracy? That if you find the error value from this from the previous iteration to current iteration, and that error should be less than some value like 0.0025 or 0.001. So if this error is less than that value, then you can tell your program that you should terminate and give it and provide your calculated value. So the termination criteria for this load flow algorithm, either you provide when it should terminate, it should terminate either by the maximum number of iteration, or it gets its error value below this some tolerance or accuracy, then the program will be terminated. So this V eta is the magnitude of all magnitude of all load node voltages at some iteration. At some iteration, we call it as ITR. So let us assume that it is given as V2 ITR, V3 ITR, and Vn ITR. And in going the second iteration, going the subsequent iteration, we call it as ITR plus 1. And this error is the mismatch of node voltage from the previous iteration to the current iteration. The maximum mismatch of node voltages from previous iteration to current iteration. So this error, if this error is less than some tolerance or accuracy value that we provide in the beginning of the program, then this algorithm should stop, and they should provide its output and final calculated value. So now let us see pseudocode for finding this backward forward sweep load flow algorithm. How you can write the code for this forward backward sweep load flow algorithm. So as I told, you have to first specify maximum value of iteration and accuracy, and then specify the base value for finding the per unit quantities. In base value, you specify base voltage and base apparent power, and then you call the data file. You are performing this load flow algorithm for some system. So for that system, the you have to make the data file, or it may be provided. So from you have to call the data file. In the data file, there are two types of data. One is node data, and other one is bus data. Upon calling this data file, now you convert this data file into per unit conversion into per unit values. So here, like what are things you have to convert into per unit values? Here you need to convert active and reactive power demand into per unit value, and then line resistance and reactances into its per unit form. So you know this base values, MVA base and KV base, and from MVA base and kV base, you can find Z base. Z base equal to kV base square upon MVA base, and then you can find all these per unit values for active reactive power demand and line resistance and reactances. Now next step, you have to apply the iteration. So perform the iteration one, that is first iteration, and you apply the while loop where your specify iteration should be less than iteration max and error should be less than accuracy. Then you have to perform the iteration. So if this satisfied, then perform the next step, that is to do backward sweep, where we determine the line currents with the help of KCL, and forward sweep where we determine the node voltages with the help of KVL. And after performing this, we will get the updated voltage, and then iteration count will increase by 1, and we determine the error. Now we got the updated iteration value, error value, and then again put in this while loop where if it satisfies, then this again loop will be again this will be loop will be run. The backward and forward sweep will run, and it gives its iteration value and error value. And in some iteration, after following some iterations, then it goes to some values where this will not satisfy, that condition is not satisfied, then it will print the results. So suppose if this iteration goes to iteration max, then we can say that load flow did not converge, because we have went through several iterations and we have put some maximum value of iterations, and in that number of iterations this load flow rhythm did not converge. So we can say that this load flow did not converge. Otherwise, if this error is less than accuracy value, you can say that load flow converges and provide its provide its voltage at nodes, and we will get the voltage at this we will get the voltage at different nodes for the power distribution network. So this is all for the revision part. So this is very simple backward forward load flow approach, where means you have need to understand how, if you have some system, we will solve one problem based on this backward forward sweep load flow rhythm. There we will see how we will apply this backward sweep and forward sweep. In backward sweep, we first find the load current, and then we will find the line current, and after finding the load current, then line current, then we will go to this forward sweep, where we will help with the help of this reference node, we will find the subsequent voltages at different nodes. So till here, any doubt? Otherwise, we can move to the problem part. We will solve these questions.
We can go for a problem. So
Okay. And if you have any doubt, you can interrupt me and you can ask. And these are simple. These are simple than you study in undergrad course, like this Newton-Raphson method and Gauss-Seidel load flow algorithm. This algorithm is simpler than those algorithms. So the first problem is that, and most problems are the theoretical type. Only 3 problems are of numerical answer type. Not means like you have to solve the problems. The first problem is that why do conventional power flow and short circuit programs typically used for transmission system studies exhibit poor convergence characteristics when applied to distribution system? And the options are shown over here. You can type your answer in chat box.
Is it C?
No, C is not correct. You have to tell the most accurate answer.
Can be C or D. Then it will go for D.
Yes, correct. D is the correct answer.
But C is also correct.
But in our presentation, X by R ratio is high for a distribution system. X by R ratio.
Yeah.
But D is saying low.
No, no. XY presentation. I have some wrong or what?
High X by R ratio. R by X ratio. Okay.
Yeah. IR by X.
In transmission, X by R ratio is high.
Hmm.
Okay. That is wrong. Thank you, sir.
Which is inverse.
Yes, R by X ratio is high. Is very high in this one system, and subsequently you can say then XYR is very low. So correct answer for this answer is D.
That means R by X ratio is high for distribution system.
Yeah, correct. For distribution system.
Here the answer is inversed.
For distribution system, R by X ratio is very high, while this XY here they are asking reactance to resistant ratio. So this one is followed. So it's very low in case of distribution system.
Yes, sir.
Okay. Coming to the next problem. Identify the correct sequence calculation involved in forward, backward sweep load flow algorithm. How are you type answer in the chat box for this problem? So we have to find the correct sequence of calculation involved in forward, backward sweep load flow algorithm.
C, sir. I think it's C.
No.
B, sir, B.
Yeah, B is correct. Load current, line current, and then node voltage.
The first thing we calculate is the load current.
Yeah, load current and then line current and then node voltage. Sir has I just let me sir has shown one very good example in lecture number 19. Here you have substation node or slack node or reference node, and then you have different load nodes. Sir has taken 3 nodes, sorry, 6 node. Is specified P plus P5 plus JQ5, and then it is specified P2 plus JQ2, is specified P3 plus JQ3. These active and active powers are given for different nodes. Q6 plus JQ6. So this is like node, or you can say node 1. So this is node number 1, where we generally take the voltage as 1 at the angle of 0 degree. And this is node number 2. This is node number 2. So the load is E2 plus JQ2, and this is load number node number 3, and this is node number 4, and this is node number 5, and this is node number 6. So if you see, first thing you need to find the load node, means the load current, and load current, that is IL2, IL3, because after finding the load current, then you can find the line current, IL6. So these are the load currents. And load current is simple, like if you want to find the IL2, then for some iteration, you can write P2 per unit minus JQ2 per unit upon this V2 conjugate. And in load flow, so in this forward backward sweep load flow rhythm, we also take, in the first iteration, we also take this voltage at all the nodes as 1 at the angle of 0 degree. So we have to assume the voltages at all the nodes initial value, and we can take it as 1 at the angle of 0. So this, for first iteration, this V2 value we have to assume, and P2 and Q2 is already known. Then you can find the load current. After finding the load current, then you only can find the line current. You know this load current, then you can find this line current, and we represent this line current as I34. So I34 is nothing but same to load current. Same to load current that is flowing from the node 4, IL4, I34, and then I36. These are line currents. And then I23, and this is I25, and this is I12. I34 is IL4, and then I36 is IL6, and then I23 is I23 is I34 plus I36 plus IL3. Similarly, you can find I25, and then you can find I12. So these are line currents. So first you need to find the load currents, and then you find the line currents. And after knowing the line current, you know the voltage at like node. This is fixed, or this
Sir,
is
I have one doubt. I23,
mm.
how it is coming? I23 is equal to I34 plus I36 is okay.
And then this
IL3, how it is coming?
this is IL3.
Okay. Got it.
Yeah.
That means summation KCL.
Yeah. So these are parts of backward sweep. And then after applying this backward sweep, you apply this forward sweep. In forward sweep, we will find the voltage. So in forward sweep, you start from the select node. Now you have to find the voltage at V2 for some iteration. So it is minus V1 minus I12 R12 plus all values are in per unit, R12 plus JX12 per unit. Similarly, you cannot find voltage directly at V4. You always have to find the volt directly. You first find the voltage at 2, then 3, 6, and so on. After finding voltage at node 2, then you have to move forward. You cannot directly find the voltage at node 4. And similarly, in backward sweep, you cannot directly find the line current, that is line current I12. You have to find from the far end. You have to find from the end nodes. So these are 4, 6, 5 are also called as end nodes. So from the last node, you have to find the line current first, and then you move toward the select node. And for voltage, you have to find start from the beginning, that is select node. It is already known. Then move. Then in subsequent of that, it is load node number 2, where you can find this voltage at node 2, and then 3, and so on, 4, 6, or 5. So it is very simple. If you know the structure, that how we determine all these things. So what is the aim of our load flow rhythm? The aim of load flow rhythm is to find the voltage at all the nodes. So how you will approach in each iteration, that to find the voltage in each iteration for the load flow rhythm. So first you have to find the load current, and then line current, and then we will apply forward sweep, where we will find the node voltage. So coming to the next problem, which of the following statements the statement hold true for forward backward sweep load flow algorithm? And in this problem, it is multiple answer question. More than one answer correct.
A and C.
Okay. One answer is correct, but one answer is wrong. Any other one? Yes. Devi, you are correct. C and D. So the first option is load flow algorithm starts with the guess value of node voltage of slack node. So for the slack node, it is generally specified. It is not the guess value. So it is incorrect. So it is not a guess value, it is specified. For slack node, it is already specified that V or delta is given. V delta is known. So it is not the guess value. The forward sweep step requires more computation than the Newton-Raphson method. Forward sweep, no, it is also incorrect. Newton-Raphson method has more computation than forward sweep method. The option is base KV of network must be chosen prior to perform forward sweep load flow algorithm. Forward backward sweep load flow algorithm. Yes, it is correct. C is correct. And load flow algorithm start with guess value of node voltage of all node. So we apply this expression. If you remember, then you apply this load current Pi minus JQi upon Vi conjugate. And if you are performing for some iteration, then we know that we need to find this voltage at different node. So initial value we have to guess.
That means all node we are considering the V1 is same.
Yeah, generally we take at 1 at the angle of 0. So this is the guess value or initial value.
Oh.
Or you can say
But
initial value.
practically all node voltage will be vary.
Yeah, means like if you assumed 1 at the angle of 0 starting, that is guess value, then you perform iteration, then it will deviate. Like it will deviate like 0.98 at the angle of 0.5 degree, and in next iteration it will deviate to 0.85 at the angle of 1.2 degree, and so on. In next step it will go to 0.86, 1.25. Next step it will go to 0.865, 1.256. So
That means
so
now IL1 is calculating, we are taking 1. IL2 is calculating the V2 is differ from the V1.
no, all load nodes, all nodes initial iteration. In first iteration you have to take this 1 at the angle of 0,
0. Okay.
and then updated value will be taken in the subsequent iteration. Like after after performing first iteration you got this value, then you have to put this value, not the initial value. Perform the next iteration.
Okay, got it.
In this code, sir has not given any code related problem or code related assignment.
Yeah,
But
assignment.
yes,
One question is there in assignment, same way.
it is there, but means initial first iteration only, not the second or third iteration. If you perform second, third iteration, then it is little bit lengthy.
Okay, okay.
Next problem is, which role does the slack bus play in load flow analysis using the forward backward sweep load flow algorithm? And it is again multiple select question.
A is one correct.
Yes, A is correct. And another one. Yes, another people can answer. D. Banarat, Ajmer.
C also.
Yes, yes,
A and
Sihab.
C. A and C.
No, A is correct. Another one. Yes, Div, you are correct. A and B are correct. Serves as a reference for calculating bus voltage magnitudes and angles, and serves as a supplier of line losses. A and B are correct. First one, it is already known because we take the reference of this select bus or substation bus or reference bus, whatever the name you can take, and serves as a supplier of line losses. So this line losses power is coming from the select bus only. So it fulfills the power losses that is happening in the line. P is helps in getting quick convergence. So there is nothing relation with the quick convergence. And sometimes whatever the initial value you assume that of load nodes, that helps in quick convergence. If we have taken initial guess of the load nodes is very that is very diverging from the its final output, means let us take that will give you more that will take more time to convert. But for slack bus, it is already fixed, so there is nothing in relation with quick convergence. But for initial guess value of load nodes, that certainly determine the convergence time. It reduces the computation. So nothing in the relation. These values are already fixed. These are not guess value. If there is guess value, then if your guess value is so much diverging from the final output that you're getting, then certainly it will take more time. A and B are correct answer. Let us see next problem. What is the common application of the forward backward sweep algorithm in power system analysis? And this is again multiple select question. In this assignment 2025 we don't have multiple select question, but last year There are so many questions in this assignment are of multiple select question. But this time you people are luckily they have not provided multiple select question this year. Yes, correct. Div, you are correct. A and C. The first option is radial distribution system analysis. Yes, we perform this forward backward sweep load flow algorithm for radial distribution network. And B option is load flow analysis mesh transmission network. In transmission network, we perform Newton-Raphson method or Gauss-Seidel method or fast decoupled Newton-Raphson. C option is distributed generation planning. Yes, this is also performed for planning purposes. And D option is power quality assessment. There is no relation with power quality assessment. So for A and C are correct. Distribution planning and radial distribution system analysis. Planning is a general term for this load flow analysis, either for distribution or transmission. But for this forward backward, we perform for distribution system network. Let us move to the next problem. So here a distribution line has per unit resistance and reactance of 0.8048042 and 1.0734. Consider base kV as 12.66 and base MVA as 100. The values of reactance and resistance in ohms are respectively. Yes, Yusuf, you are correct. A and C are correct. Now, for this question, you try. This is also very simple. Yes, Yusuf, Dev, Ajmer, Shihab. Anyone got the answer? So, what are the things given here? Per unit resistant reactance values are given. Given R per unit, that is 0.8042.
Is it
And
A?
no, A is not correct. X per unit is given as 1.0734. 0734 and kV base is given as 12.66 kV and MVA base is given as 100 MV. So from this kV base and MVA base, we will find the impedance Z base, that is so can anyone tell what the expression of Z base?
KV square
MVA
divided by
base by
MVA
KVA base. KV base.
KV square by MVA base.
Yes. Yeah, you are correct. KV square by MVA base. Twelve point 66 square upon MVA base 100. It will give you 1.6027 ohm. Now they are finding we have to find the reactance and resistance in ohm. So we know that R per unit is R ohm upon Z base. Therefore, R ohm is R per unit into Z base. So R per unit is 0.8042 and Z base is 1.6027. So it will give you 1.2889 ohm. And X ohm similarly will find X per unit into Z base. X per unit is given as 1.0734 and Z base is 1.6027. So this will give you 1.7204 ohm. So which one is the option? So here they are first asking the reactance. So be careful. So X ohm is 1.724 and R per R ohm is 1.2889. C option is correct. So they have given B option also. Many of you may do mistake by putting answer as B because we are generally in habit of finding the resistant value first and then reactance value. But in the problem, they have they are asking about reactance value first and then resistance value. So C option is correct. Yes, they also did same mistake because here they are asking reactance value first. Now again theoretical type question. So again this is multiple select question. In load flow analysis of distribution network, which type of system can we consider? Options are balanced system only,
C and
both
D.
balanced and unbalanced systems. C is weakly meshed system and D is unbalanced system only. Yes, I think someone is telling the answer.
B and C.
Yeah, you are telling
B and C.
B and C. Okay. Any other one? I think this is a very simple problem. Dev, Yusuf,
Yes, sir. B and C seems to be.
yeah, correct. I don't know if people are first means in the first attempt giving the right answer. In the last year, many people have done mistake in this problem. They are giving the answer as A and C. So the correct answer is B and C. So are you aware of this that we can apply in a balance system also? Because there is one for balance system.
That means a distribution system is unbalanced system, but it is possible to use for balanced system also.
Yeah, correct. But this Sarah is on for only balance system only, na. That's why many people did mistake.
Okay, okay.
Sarah is not considered in balance system. In unbalanced system, things will little bit algorithm will little bit changed. You will see many research papers based on this load flow sweep, this backward forward load sweep algorithm for unbalanced system. So correct answer is B and C, both balanced and unbalanced system, and C is weakly mesh system, or that is also called radial system. So this is for all the theoretical type problem. Now come to this problem 8, 9, 10. That is similar to your current assignment also. So here we are given with a radial distribution system with 6 nodes N1, N2, N3, N4, N5, N6 as given in the flowing figure. Node N1 serves as the substation node while the remaining 5 nodes are designated as load nodes. So we know that this first node generally we take it as substation node. Substation node, like node. The loads at N2, N3, N4, N5 consume real and reactive power with the flowing specification, and node N6 also. These all are load nodes. Assume a base VA of 100 MVA, base kV of 15 kV, and initialize the voltage as 1 at the angle, 0 phase angle. So you have to assume the initial voltage at 1 at the angle of 0 degree. So in the 8th problem, you have to find the phasor drawn by the load at node N3. current drawn by the load at node N3. So you have to find the I N3. At the first iteration, forward, backward, sweep, load flow. So they are telling you to find this load current, that is IL3. Load current at node 3. So they are asking you IL3. So we have represented this load current by IL. Don't confuse with this. You can represent by any base. Load current at node N3. So what we can do, we can find all the load currents. We can find all the load currents because in the next problem they will ask the line current. So it's better to find the all the load current.
Can you repeat what you told now, sir? IL3 load current at node 3 means?
We represent load current by N3. Sorry, IL. That's why we represent this IL3 as load current at on node N3.
Okay.
You can assume, you can represent by any way, no problem. So let us find all the load current. So in this they are asking about the load current at node 3 only, but let us find all the load currents because in the next question they are asking the line current. So at load 2 we have P and Q as 100 kilowatt and 100 kVA, and load 3 is of 100 kilowatt and 60 kVA. Load 4 is 200 kilowatt and 130 kVA. Load 5 is 250 kilowatt, 25 kVA. Load 6 is 220 kilowatt, 175 kVA. If you got the answer, you can type on the chat box also. So let us find the load current at 2. So IL2 is load current at node 2 is P2 minus JQ2 upon V2 conjugate. So here all the initial values in question it's taken as, we have to take as 1 at the angle of 0. So if you write its per unit value, so if you write its per unit value, then we have this MVA base, and MVA base is given at 100 MVA. So it is similar to 100 into the power 3 kVA. So 150 upon 100 into 10 to the power 3 will be 0.0015. So it is 0.0015 per unit, comma 0.001 per unit. Similarly, you can write for another one 0.001 per unit, 0.0006 per unit, 0.002 per unit, 0.0013 per unit, 0.0025 per unit, 0.00125 per unit, and for load 6 is 0.0022 per unit, 0.00175 per unit. So we have found the power
Got this
demand
value, sir? How you got this per unit?
per unit value we got by this. We know that this P per unit is P actual upon kVA base, or Q per unit is Q actual, and P is given in kilowatt. Q kVAR upon kVA base. So we have, and kVA base is what? kVA base is 100 into 10 to the power 3 kVA. It is given in the problem. So if you see, it is given as base kVA as 100 MVA. 100 MVA means 100 into 10 to the power 3 kVA, right?
Yes, got it.
So here you have to write the answer in per unit. So P2 minus JQ2. So P2 is 0. Now it is very simple, 0.0015 minus J 0.001 upon V2 conjugate. V2 conjugate is 1 at the angle of 0 degree. So it is 0.015 minus J 0.0 per unit. Similarly, IL3 P3 minus JQ3 upon V3 conjugate. P3 is 0.001 minus J 0.0006 upon 1 at the angle of 0 degree. So it is 0.001 minus J 0.0006. Now IL4. So all this initial value like V2, V3, V4, V5, V6, like they have told inside the voltage by 1 at the angle of 0. That's why we are taking V2, V3, V4, V5, V6 as the 1 at the angle of 0. P4 minus JQ4, V4 conjugate P4 is 0.02 minus J 0 upon 1 at the angle of 0 degree. Similarly, IL4, IL5. Five is 0.0025 minus and IL6 load current at node 6 is E6 minus JQ6 upon V6 conjugate equal to 0.0022 minus 0. We have found the all load currents. But in this problem, they are asking the load current at node 3. So the correct answer is this one. So the correct answer is IL3 equal to 0.001 minus J 0.0006 per unit. So this is the answer for problem number 8. So if you match from the problem, then it is coming as C as the correct answer. J 0.001 minus J 0.006. No, C is not correct. D is correct. 0006 per unit. You note down all this value of load current at different nodes, and then we will move towards the 9th number problem. I hope you all noted down this load current at different nodes. Now let us see the 9th problem. So the data is same for this problem also, but here you need to find the line current. You need to find the current flowing in the line L2 in per unit at the first iteration of forward backward load flow. So we have to find the IL3. We have to find the line current flowing in the line L2. So this current we have to find. So let us represent this current as I2. So if you see this current flowing through this I2 is how much? All the load current that beyond this line. So the first one is IL3, load current at node 3, then IL4, then IL5, and then IL6. So this is the calculation you need to do. So I am just providing you all these values and then you tell me the answer. IL3 is 0.001 minus J 0.0006 per unit. Then IL4 is this one. IL5 is 0.0025 minus J 0.00125 per unit. And IL6 is 0.002 minus J 0.00175. So you do the summation and just tell me the answer. I got one response. Div is saying see the answer. Yes, see the correct answer. If you do summation, then C will come as the answer. So I2 will come as 0.0077 minus J 0.0049 per unit. So this is the answer. Now let us come to the last problem of today's session. So the last problem, in this problem we have to find the substation voltage. You have to find the voltage at node N2. So you have to find this voltage at node N. You have to find this voltage Vn2. So we know this Vn1 or V substation. We know that V substation or Vn1 is like node or reference bus. So Vn1 we know that this is 1 at the angle of 0 degree. So this is known, and impedance of the line connecting substation and node N2 is given. This is given 0.74 plus J 0.34 ohm. So this voltage is known, this impedance is known, and you need to find the current through this line. So first you find the current. Let us take this as I1. Then we will apply the KVL and we will find the node voltage as N2. So it is very simple. So Vn2 is how much? Vn1 minus I1 into J 0.74 plus J 0.34. Sorry, this one is given in ohm, so you have to convert. So you have to convert in per unit. So R per unit plus Jx per unit. So we have to find this one, and unknown things are I1 and then R per unit and X per unit. Let us find first. Let us find first this R per unit and X per unit. So what we know? We know that Z base is KV base square upon MVA base. So KV base is given. So KV base is given as 15 kV and MVA base is given as 100 MVA. 15 square upon 100. So it will give you 2.25 ohm. Now you have to find the R per unit plus X per unit. Jx per unit. So it is how much? R plus Jx actual value upon Z base. So R is 0.74 plus J 0.32 and Z base is 2.25. Can anyone tell what is the value got in per unit? Anyone can tell this R per unit and X per unit?
Point 038 328.
Yes, R per unit is 0.328. X per unit 0.3289. The next per unit. We were telling right. Why you stop? Yes, the 0.328 and 0.15. No, 0.15 is not coming. 0.142 coming.
Yes, 0.14.
0.142. So this value we got for impedance in per unit. Now we need to find this I1. So I1 is nothing. We have already found, I think what we have found, we have found this I2. We have found this I2, and we know that this one is IL2. So I1 is nothing but this is I2 plus IL2. So let me write this I2. I2 we got as 0.0077 minus 0.0049, and IL2 is 0.0015 minus J001. Now tell me what is the value of I1? See half and leave. You have to just add
0.0092 0.0092 minus 0.0059 J.
That's correct. 0.0059
J.
per unit.
Yeah,
Now
per
we know all these values. Just we have to substitute in this KVL equation. Vn2 equal to Vn1, that is V substation, minus I1 into 0.0092 minus J0.0059. So here we have applied this backward sweep and then forward sweep.
And this much calculation, how we will do in examination? Because calculator and there is no pen and paper.
Pen and paper is there.
pen and paper we can use?
Yes, they will provide you a scribe pad.
Oh, okay,
But
okay.
just
Then
like
okay.
GATE exam.
Okay. Calculator only, the display calculator only.
Yeah, GATE calculator.
Uh,
That is called a scribble pad. And that is, or they may give you rough page also. That you have to return after the exam.
After exam. Okay.
So I1, sorry, I did mistake here. So this is R per unit plus Jx per unit. So Vn1 is 1 at the angle of 0 degree minus I1 0.0092 minus J 0.059. If you got the answer, you can type in chat box. 0.3289 plus so it is minus 0.00386 minus so anyone can tell what you are getting. Let me write the answer 0.996135 plus J 0.000632, that is 0.9961353 at the angle of 0.03635 degree. And they are asking about the magnitude of voltage at N2. So magnitude is 0.9961. So this much magnitude. So if you match from the answer, then I have not written the answer here. You first option is 0.9961. Second option is 0.935. The option is 0.96. The option is 0.985. So A option is correct. 0.9961. So that's all for today's session. And we still have 15 minutes time. I quickly revise all the previous assignment. You just go through all the problems that will helpful your exam and for this current assignment also. So these all are critical answer type for 2023 assignment. Nothing new. Similar type problem that we have solved right now. And now come for 2022 problem. It is upon base per unit value, and then backward sweep what we found this line current, and then node voltage we find be updated in forward sweep. And this question is the forward backward sweep load flow algorithm start with guess value of what. This is one of the common problem that where people do mistake. We take the guess value of load nodes, not the slack node. Slack node it is already known, it is already given in the problem. But for load nodes, it is not being provided. We have to take the initial guess. So for the load nodes, we take the initial guess of voltages for different loads, for different nodes that we have to keep in mind. Not for the slack node, we take the guess value. For slack node, it is already known. For load nodes, P and Q are known quantities, and V and delta we have to determine. We have to determine, so that first we have to take some initial guess. So which of the following step need more computation? Backward sweep needs more computation than forward sweep. So here, what are the parameters are specified for load nodes? Load nodes, as the name is specified for load, what are things we need to know? Active and reactive power. So it is similar type, means how we can find this load current. What are data of distribution lines required to perform the forward backward sweep load flow algorithm, line resistance and line reactance? The competition of forward sweep start with substation node or slack node. The competition of backward sweep start from the distant node beyond which there is no node. So from the name itself, it suggests that backward sweep start from the most distant node or end node. So it start from the end node, while the forward sweep it start from the substation node or slack node and be moved forward. So that's all for today's session. If you have any doubt, any concern, you please ask. Attendance is really poor. I think course is little bit you are comfortable in solving the problem assignment. That's why. Are you
Clear,
able
sir.
to get? Are you able to get the like more than 90% or 80% in assignment?
Yeah, it is getting, sir. Till now, 100% is getting.
Very good. You are able to get in this what we call assignment. Then you are very comfortable in the exam, because I think
Yeah.
30% bet is there, na?
Yeah. But your live session is more convenient
live
for answering.
Yeah, means like recorded sessions is also okay, but a live session that will more remember, means
Yeah,
you will
more
remember.
more clarity will get. Professor video batch and then your live session also. Then it will very helpful for solving assignment.
Yeah, because you are actually living that hours na. Recorded session what you can means you can read or you can watch video lying on the bed. You can going on, means like you are traveling. You can also watch video. But for attending any class, that will not forgettable easily. It will means it will you can remember more time than if you watch the recorded session.
Yes, this
That
2 hours is
that
very beneficial.
Yes, that is true for all the cases.
So the
Sir,
end examinations, the questions will
Yes,
be equally from all sections.
yes, all the assignments. If you miss, they are more typically more or less assignment type problem, and they have equivalent weightage. Missing,
So similar to the
I cannot.
assignment questions, but the number will be different. Yeah, that's right.
Yes, it depends upon the how they set the problem, but weightage will be, I think, more or less similar. They will not ask more problems from the starting part of course or later part of question. They will put all the equivalent weightage for each assignment, and this is definitely sure that they will touch each and every assignment. They will not they will not left any part of the course. They will touch each and every part. Either there may be miss I am not the course instructor. There may be chance they will ask one or two question less from some assignment, or 1 or 2 marks, not question 1 or 2 mark less, but they will touch each and every part. So the stable thing is that you just uh, go through course all the parts of course, and if you are having trouble in some part, then it's okay. Means you later learn on, but for easier part, means for easy questions, you should give the answer in the exam. For easy question, you should not left any easy problem in the exam. That is the first motto. Because in tough problems, there may be mistakes. Every student will do mistake. But in easy questions, if you go thoroughly through the course, then I think you will be able to give the answer.
We'll have the time to solve all these big questions, long answer, because that need more steps.
Yeah, because in the assignment there may be some longer questions, but in the exam there is chance that they will ask question that type that will take calculation less, but you should know the concept. They may give you problems in which this data is very easy. Means you do multiplication division very easily as compared to this assignment, because in exam we have virtual calculator. So this uh, instructor or those who shared the problems, they know that this type problem face, and they generally 3 hours slot is there, so they usually keep in mind. It's like a excellent student is able to solve in 2 hours or 2.5 hours. Don't worry about that. Means like you should know the concept. If concept is easier and you are in flow, means you are able to solve the problem, then there is no problem regarding that you will track in the calculation part. They give you easier data. I hope, hopefully, I think so. I'm not sure. Means
We can
whatever
we
I'm
can
saying.
write we can write in the paper and solve it, isn't it?
Yeah, paper they will definitely provide. This is 100% I'm sure. I have also given so many NPTEL exam.
So they'll give the
Means,
papers. Okay, we can solve in that paper. Write it and do it.
yeah, you can solve in the paper. You can write on the paper, and in the paper means like some big calculation is required. Then you have to definitely take the help of calculator. You cannot do multiplication and division, or you can find the uh, angle of something sine or cos theta in the what you can say. You cannot find. You have to take the help of calculator. They will give you the rough exam or a scribble pad, rough paper or a scribble pad. That is sure. And in that scribble pad or rough paper, you have to write your whole number and name. And in after the exam, you have to hand over to the those who are taking the invigilator duty. Have you not given the NPTEL exam? Yes, so.
No, this is the first time we are doing.
Okay.
Me too.
Hopefully, Okay, yeah. So you will have very nice experience. So this NPTEL exam is very very convenient. All things are very running in time, and maximum chance you will, if you just put little bit effort, you will get elite plus a gold certificate. There are 3 types of certificate, 3 or 4 types. If you see elite plus gold, elite plus silver, or simple elite, and then pass, something like that. Those
Based
who
on the
get
marks.
those who get more than 70%, they will get elite plus gold. I think so, something like that. And if you become topper, then you will get also one topper tag in the certificate. Topper means the number of students who are participating, you are under the 5%. Means the 5% who got the maximum marks, 5% of students are considered as topper from the top. So there based on the number of candidates, top 5% will consider as topper. And if you once become topper, then the NPTEL will give you many opportunities for certainly for bachelor student. For master and PhD student, they will not give so much opportunity if you become topper. Like if you become topper, first thing they will give you that you can do internship in IIT. Means suppose you become this topper in this Sanjeev Ganguly sir course, then you can have opportunity doing internship in IIT if you are bachelor student, and they will give you a stipend some also. Well, means I think 15,000 or something. And also if you become topper or something, if you have become top, uh, some star certificate in PTL star, then you can have also some post baccalaureate type of internship. For 1 year, they will give you HRA plus a stipend. Before you start PhD, you have just a glimpse of research. You can go to this. You have many projects be floated. You will get mail once you have these tags. You will get mail like these many projects. If you are interested, you can go to that college. You fill the form, and the professor will select you, and you can stay there for 1 year, and you can do some basic research before joining PhD. So there are many advantages of NPTEL courses because these are government supported. Basically, first thing that. I think all of you are means like either means industry based or some college. You are masters or PhD students, right?
Yes, sir.
For
Yes, sir.
bachelor student, yeah, for bachelor students there are so many advantages. But for master PhD, we cannot do na. We cannot join internship, or we cannot join for 1 month internship or 1 year internship, 1 year something post baccalaureate degree or post baccalaureate certificate, or what they are called. I don't. For 1 year, you have to, before joining PhD, you can do research in some project in some IT or wherever these projects are floated.
Sir, some
Okay.
courses, some NPTEL courses, there is no any live session. It is mandatory or not?
Actually, it depends on the course instructor. Some course instructors are very reluctant. Means they are reluctant. Means we are also PhD student. We are in. I am in 4th year PhD student. So we may teach wrong. So they may hesitate to take some TA. So that is
Oh.
so that's why they. It's like for first time course, it is not they will not float PMRFTA, but for second time, like this course is being second fourth time, so like this fresh course, like it has not happened in last year, so no PMRFTA will be there. But those course that is being already available and that is rerun, means like this course is already available in last year and it is rerunning in this, so they can assign PMRF. But I'm not 100% sure why they are not taking this PMRF PF for relearning course. I saw some courses that are actually running again and again, but there is no TA in that course. But for fresh course, means like that is being recorded this year, there will no TA because we don't have previous assignment.
Yes.
Hmm.
Do you have a good idea about power quality, sir?
Yeah, power quality I've taken it is
Yeah.
my guide work is on power quality only.
Yeah,
My guide
I,
name is
I,
Dr.
I
Chandan
have
Kumar.
your mobile number. I will contact you, sir, personally.
My guide has done PhD in power quality. I'm
No,
doing
I have
I'm
some
doing
doubt
work on
about power quality, some issues, problems. I will contact you, sir.
okay, sure. Okay, then we can close today's session and we will meet on the next Sunday. Thank you
Okay,
for
thank you, sir.
joining. Good night.
Thank you, sir.
Thank you,
Thank you.
sir.
Thank
Good
you, sir.
night.
Welcome.